How long do you guys want this lesson to be? Do you want the 7-minute lesson or the 37-minute? 7? Okay, I'll shoot for 7. It'll probably be 12. Today is the 16th, and I know that because tomorrow is my wife's birthday. So today is 1/16/23. You guys want to guess how old my wife will be tomorrow? Come on. Come on, don't you want to play my game? What a guess, 48. Impressive. She would have you believe that she's still turning 29, but that's not true. This, like I said, this whole unit should take a weekish. So what's nice about this unit always is that when I teach it, it's awesome because you've pretty much got all the requisite skills. You know how to graph lines, you know how to get y by itself. You know that with inequalities, we have to, if we divide by a negative, we have to switch the sign. Like all the requisite pieces are in place. So this lesson is pretty short just because I say there shouldn't be any points along the way where you go, like, I don't know how you did that. So the idea here, and I'm going to start us off nice and easy, is that I'm going to give you things that look like slope-intercept equations, but they're not equations. They're going to be inequalities like this. And we've done some work with inequalities before, except we haven't referred to them as linear inequalities. They were just single variable inequalities. Do you guys remember that unit we did? It was like 3 months ago where you had to get x by itself, but I tried to get you to always put x on the left because we wanted our answers to say like x is less than 5. And then on the number line, we would put a circle and try to decide if the circle was open or if we'd color it in and then we'd shade one way. This is like that, only the 2 variable flavor of that. So this is not just regular like single variable inequalities like we did back in our equation unit back in September or October. This is, what's up, Levi? How you doing today? All right. Glad you could join us. So what's going to happen here is, and by the way, the starting out giving you y by itself, that's just kind of a gift. And as I looked through your assignment, most of them don't have y by itself already. I did find, because sometimes I go a little click happy. You'll be in Delta Math today. I go a little click happy to just try to see what's coming down the pike. And I saw very occasionally problems where the y was already alone. But usually you're going to have to get y by itself. But let's just start with this so we can get the basics of how to graph these things out of the way. First off, more for 9th graders. Have you guys done this before? Did you do this with Mr. Manlove last year? You probably don't know yet because you still don't know what we're doing. So let's start by just sketching some axes. So it's kind of hard to take notes, I know, with graphing things, but you can figure it out. You guys are pretty industrious. So imagine for a second that instead of saying y is less than, that it said y is equal to. You're like, I like this graph. This is easy. Where would I start my graph at? Don't say -3. Thank you. We're going to go down 3, remember, and put our first point. It's just the same thing. I'm going to write this in red. It's the same thing as if I wrote y equals 1/2 of x minus 3. Basically, that's the line that we're graphing, but don't connect your dots yet because there's a little bit of a twist here. So I am going to start by going down 3. 1, 2, 3, and I'll put my home base there. And what is the slope of this line? So I'm going to go up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2. And as you know, we want to do that enough times so that we're connecting dots that are pretty far away. You don't ever want 2 points that are like a 1/2 inch away from each other. That's how bad lines get created. So normally months ago at this point, you'd be like, this is easy. I would just make a line, like whatever. But I ask again, you guys remember the whole open circle, closed circle thing? This line, when I graph it, I'm just going to show you what this looks like, and then I'll kind of show you a trick to this. This line is actually what we call dotted. Some people call it a dashed line. Have you ever seen one of these before? You ever seen that? So what this does is this shows the reader of our graph that the points on the line are not solutions. So when I go to graph this line, what I'm essentially doing is I'm setting up a boundary. And now, believe it or not, the graph is going to look like this. And this is probably going to freak you out a little bit, but the graph, oops, that's not the right graph. The graph is going to look like this. Is this looking familiar at all? I always just kind of like to know if this is something you've ever seen before. Hmm? So let's think about this for a second and just take a look as to why would I vandalize a perfectly good graph like this? Well, take a point like, I don't know, can you see this green point right here? Of course you can. You would agree that that's below the line, right? What are his coordinates? Can you tell me that? Like, what's his name? Ah, the green dot, yes. I'm pretty sure, mhm, I agree that his name is 6, -1. Now, if I put those numbers, and you don't have to do this every time. I'm just doing this so you can maybe get a little insight as to why we graph this way. If I were to put those numbers back into the original problem, let's take a look at what happens. So what am I going to put in place of y? Good job. And it's going to say -1 is less than. And can you help me with this little math problem here? What is half times 6? Because I want to put 6 in place of x. What would that be? 3. And then if I check the math on this, it would say -1 is less than 0. And assuming you passed like the 4th grade, you would agree that that is true, that -1 is less than 0. It's not equal to 0, but that's not what we're doing. We're not graphing equations today. We're graphing inequalities. And how many points do you think I could find for which this happens, where when I put the numbers in, it comes out true? All the ones that are down there. Anything down in that yellow shading, and I could go infinitely far. I could go 2 miles to the southeast, and I can keep going down. I could go to like the point 1 million and -1 million, and I guarantee you, when you put those numbers in place of x and y, it's going to come out true. So let me give you some steps, and then we're going to go through and do some more, and this will make a ton of sense. So let me switch backgrounds too and give you a fresh page. So when we do these problems today, step 1, you'll want to probably write these down. Step 1 is to get y by itself. And I'm going to put a little comment here, if necessary, because like I said, on occasion, you get one where you're like, sweet, y is already by itself. And then step 2, I'm not going to say graph the line. I'm going to say make some points. And you know how to do that. You've done that 100 times with y equals mx plus b, right? You know where to start. You know how to do slope, I presume. Step 3 is going to be to graph the line. Now, step 3 has a little bit of clarification necessary. So when I graph the line, I'm going to either do dotted. You can call it dotted or dashed. I'll call it dashed because I kind of feel like it's more dashed than dotted. Or it's going to be solid. Do you guys want to throw out a guess when I made my graph as to why I chose to make it dashed and didn't leave it solid? I don't know why you would know the answer to this, but looking back at that other page, bless you, can you think of a reason why I chose to leave it dashed and instead of making it solid? Something in the problem that would make us think that? Do you guys remember with inequalities how what made us do an open circle versus a closed circle? Good job. And so in this case, good memory, Tegan. So this is kind of like our version of an open circle and closed circle. And what we're trying to do by making a dashed line is show people, and I'll show you this in a second, that the points on the line are not solutions. Anything to one side of the line is a solution, but the points on the line itself, those points, they're not solutions. So in that other page, when we're writing down our steps, let's make a little comment here that it's dashed if it's just greater than or just less than. And then, of course, it's a solid line if it's greater than or equal to or less than or equal to. So this is kind of our new thing now. Instead of colored in circles or hollow circles, we have dashed lines versus solid lines. And then step 4, and then I'll go back and do a little bit of clarification on that other page. Step 4 is shade the correct side of the line. So after you get done writing down these steps, I'm going to flip back over to my graph and ask you yet another question, and then we'll start practicing more quickly here. Everybody good on the steps? Okay, take a look at my graph. What do you think in the problem? I mean, yeah, I've done this, but I mean, it's easy. What do you think in the graph made me choose to shade below the line? In fact, you saw me start to mess up. I started to shade above and then was like, oops, and then I erased it and shaded below. What do you think gave me that cue? Yes. Basically, this problem up here in this red box says I want all the y's that are less than the line. And so all lines have an above side and a below side. And if it says less than, you shade below. If it says greater than, you shade above, provided that you've done a good job of getting y by itself, of course. So one more thought on this. Just going to kind of milk this example dry, and then we'll hit a couple more practices. I want you to see what happens. I'm going to make a big blue point, and I'm going to make it right on my line. So I'm going to throw this background back in here, and let's do this blue point. You all would agree that that blue point is right on the line, right? Can you tell me, bless you, can you tell me what his coordinates are? Oh my goodness gracious. Did you see that? Sorry about that. Can you tell me what the coordinates of the blue point are? I think it's 2, -2. Everybody okay with that? Let's watch what happens now when we put those coordinates back into the original problem. So here it goes. Instead of writing y is less than, or instead of writing y is less than, I'm going to write -2 is less than. And again, I need your help here. Look at my little blue box up here. What is 1/2 times x, or in this case, 1/2 times 2? And so I get this statement right here. And math people, you'll appreciate what's happening right now. You'll say to yourself, this is not quite true. Is -2 less than himself? No. But if there were an equal sign, if it said or equal to, then you could say, oh yeah, -2 is less than or equal to himself. But you're going to find this result right here for every problem on the line, or every point on the line. I could pick this point, this point, this point, this point. Any one of these blue points is going to return the same thing. A number is less than himself, which 100% of the cases is false for this line. You agree? So that's why this line is dashed and not solid. Let's try another one. And I just want to give you one more little simple pimple warm-up problem, and then we'll get to getting y by itself. And then that'll be that. It's really not much to it. So let's say I gave you y is greater than or equal to -x plus 1. Where would I start my graph at? I would go up 1. Very good. And what's the slope? Like, how would I utilize the slope? I understand that the slope right there is -1. So don't tell me that. I mean, give me English directions as to how to interpret that. What does that mean? How do I do that? Perfectly spoken. Down 1, right 1. down one, right one, down one, or up, left, up, left, up, left. You've been around me long enough now to know that I'm not going to be sweet and loving and supportive if you're putting downhills when they should go uphill and vice versa. Will this line be solid or dashed? Solid in this case, why? Because of the or equal to. Very good. And so with a line like this, you don't have to go back and erase part of it away. Or, I mean, just dash it in the first place. I mean, it's like, there is my boundary. We call that a boundary, by the way. It's a line, but what it's really doing is it's establishing a boundary to say all the points on one side are good, all the points on the other side are bad. And which side do you suppose we ought to shade? Why would you say that? Nope. Has nothing to do with the y-intercept. You are correct, by the way. You should shade the top side, which I hope you all agree is this side. But why? Why is that? Because it's greater than, right? It has nothing to do with anything else. If it says greater than, you shade above. If it says less than, you shade below. Nothing to it, right? Okay, let's do an example where we have to actually get y by itself. So there's going to be a little bit of work, some old basic skills coming into play on this problem. So let's do 3x minus 2y is less than 8. Okay, so what's step one? Let's do it. What do we do first? That's what I would do. Let's subtract, and I like to just keep y right where he is, right? No silly business about making y positive. Don't put him on the wrong side. Let's leave the minus 2y right where he is and do what Brenda said. So I'm going to subtract 3x from both sides like this. You've done this hundreds of times by now. These are going to cancel out, and I'm going to be left with negative 2y is less than, and how will I write the right side? It's not wrong, but I don't like it. 8 minus 3x is not wrong. It's just, remember how we want them to look a certain way? So we'd want to put this first, negative 3x, and then plus 8. It helps us when graphing lines if we always force y equals mx plus b in that order. So again, what you said is not wrong, but try to keep that x term always going first. And now what do we do? Divide everything. And so we're going to divide right here by negative 2, and we're going to divide right here by negative 2, and we're going to divide right here by negative 2. And I'm going to cancel these out, and then I'm going to write this. And you're going to think maybe that I've lost my mind. Y is greater than 3 halves of x minus 4. We're a little rusty, and it's been a long time, so something about that should make you want to ask a question. Maybe you want to call the nurse because you think I'm having a stroke or something like that, but I did not mess up. Do you notice anything a little weird? I did switch the sign. This thing used to say less than, and now, if you're paying attention, you're like, what? Now it says greater than. The same rules apply as they always have. If you divide by a negative, you got to switch your sign. And that matters because that's going to change our decision as to which side of the line we have to graph. So let's make a sketch. I feel satisfied that we're okay with that. So we're going to make some axes, some x-axis and some y-axis action over here. And now we're ready to begin our journey. At this point, the only thing we're looking at is this equation in this red box. Nothing else at this point matters to us. So where do we begin the graph? Down 4. 1, 2, 3, 4. And how do you utilize a slope of 3 halves? 2, 3, 1, 2, 1, 2, 3, 1, 2. That should be enough. And at this point, you just have a mild decision to make. So 1, 2, 3, 1, 2. You can just connect the dots like such. And I do it this way because the technology that I have up here to teach you with, it's easier. My tool doesn't have a dotted line option. You have a dotted line option, and it's just that when you put your ruler down, you just go line, space, line. Like you pick up and put down your pencil over and over again. For me, I have to go back and cheat it a little bit like this. So I make my line dotted like that. You can come up with your own way. I don't really care. And at this point, remember, the line is not the answer. The line is the wall that determines the set of answers. The set of answers is an infinitely large, what we call a half a plane. It's infinitely many points. Which side should I shade? The top side. And if you were to do something like go back to the beginning of the problem, you might say, but it says less than. And I say, doesn't matter to me. I only care about my final answer. Once y is by itself, it says y is greater than, and the top side of this line is obviously up there like that. So let me show you what this looks like just real quick in Delta Math, and then I'll be done. That was a little longer than 7 minutes, but that's pretty good for me still, I think. Let's see. Show desktop, Delta Math. And your topic will be graph linear inequalities. All right, so let's work through a problem together and make sure you guys are good. Help me out if you'd be so kind. I'll show you how this works. So you can see the problem up here. I hope I'll zoom in a little bit for you. Maybe. Can you guys, you can all see that. You guys have good young eyes. So what do we do first? Right, and how would I do that? Subtract the 3x. So my next line is going to say 4y is less than what? Remember, we're subtracting 3x. Thank you, Alina. We're subtracting 3x. So we have negative 3x plus 12. Good. The 12 stays plus or positive because we didn't move him. And then what do? We divide by 4. Will we be switching our sign? I know why you'd say that, but not in this case, because we're not dividing by a negative. So it only happens if you divide by a negative. And even though the 3 is negative, he's not who we're dividing by. So we're going to leave the signs the same. So the flip only happens, your Pac-Man only reverses east-west if you divide by an actual negative. So we're going to keep it the same. And we're going to say, okay, here it is. Bless you. We're going to say y is still less than, what's my slope? Plus. Good. So you can see, I mean, you don't want to mess that part up. Otherwise, the whole thing is like, well, now I've done it. So the rest of this, I can just now click. You know, Delta Math has a nice graphing interface. And so what I'm going to do is start my graph by doing what? Up 1, 2, 3, click a dot. And the slope is negative 3/4. You've done this before, so you can just move your mouse around and it'll wait for your next point. How do I do negative 3/4? Good. Thank you for not saying over. You're a champ, right? Down 3, right 4. And all you have to do is click one more time. Now notice there's a couple boxes and they say change line and change shade. So do we like the line solid or do we want it dashed? We want it dashed. So I just click on change line and it makes it dashed. And right now there is no shading. So if I click change shade, I have these options. Doop, 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 doop. Which one do we want? We want below because it says y is less than. And so I like it just like that. It's really easy. That the interface couldn't be slicker. I wish I'd had this technology when I was teaching, 20, 25 years ago. It's super slick. So paper is where you do all the algebra to get y by itself. And then after that, it's just click, 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 boom, done. Easy. You guys got it? Okay, good job. If you have any questions, because sometimes I forget to say things, just let me know. Try to get this done.